Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is to implement arrays and circular buffers on our library for developing JSFX, particularly JSFX that are good looking, and we are developing a whole design system for this. And in case you don't know what JSFX are, then how did you find me? JSFX are these real-time audio effects, audio processing thingies in REAPER. And if you don't know what REAPER is, that's a digital audio workstation. It allows you to process audio and video. You are hearing me through REAPER right now. It's processing my voice. And yeah, so we have this library. It has a bunch of things in there, like a design system with colors and spacing and whatnot. But I think that my library also needs some basic data structures, because in JSFX, all you have is just one big chunk of memory. You have to manage that big chunk of memory yourself. And in the library, I'm going to give you a bit more structure. And by you, I mean an effects developer, not a person who is using audio effects. So if you are developing an audio effect, you need a bit more structure to help you organize that big chunk of memory. And I'm going to give you arrays and circular buffers. We have already implemented some sort of memory management that allows you to allocate memory, and we have enumerations and we have structs. And I mentioned this because we are going to use some or maybe all of these to implement arrays and circular buffers. Now, let's start with arrays, because a circular buffer definitely is a kind of array, so it will use an array as part of its implementation. So what is an array? It's just a chunk of memory that you index with a number. And Reaper already gives you that. So why am I saying that I need to implement an array? Well, it is because I need to organize the array that you're using with the rest of the memory. So maybe let's start with how I want to be able to use an array. So I have here the library that I'm working on, and here is an example of using the library, which is also sort of documentation, and it's an actual JSFX that I have loaded here in Reaper. Right now, what it does is just show you the colors in the design system, and there is a very crude unit testing system in place. And that's these check marks, because the tests are passing. So in here, I can start using an array. I have not defined how the array is even constructed, but we can pretend that it's there and we can try to use it. And then we implement the thing so that it actually works. So this is the end of the memory allocation stuff. So my array needs to come before this. And why would I need an array? So let's think about an example of why I would need an array. Maybe I have a filter and I have some coefficients. So I'll create a coefficients array. And all my library functions are prefixed with L underscore. It's sort of a namespace thing. So I guess I will say array new. Or maybe even define. No, this is actually the allocation of the array. In the struct, I have to define the struct and then allocate the struct. And in enumerations, there is no notion of allocation. But in arrays, I don't have to define an array and then use the array, because there are no multiple fields in the array. But what I do need to do is to give it a size. So let's say that I have 10 positions, or maybe because these are coefficients, maybe I just have like 4 of them. And then how do I use the array? Well, this is in the init block. I'm just initializing the array. I'm allocating that space for me to use. So I don't think I'm going to put the code that is actually going to use the array over there. This is just allocating the array. Let's scroll down and find the place where we have some right after the label stuff, I will have a test for the array, the coefficients. So I'll say coefficients at a certain position. So maybe something like 0 is equal to 0. Oh, that's kind of boring because in JSFX everything starts with a 0. Bo says, hey Leandro. Hey Bo, great to have you here. I hope you enjoy the ride. In case you haven't noticed, what we are doing is we are writing the implementation of arrays. So we have an array of 4 positions, so we should have these 4 indices to use, and I will put some values in there. Bo says, arrays are great for sorting algorithms. Let's say you want to do a Gaussian filter or median. Okay, yes, that is a good point. We could have some sorting algorithms. I think it was you who asked for this before. Some basic algorithms like sorting and searching. And maybe we could have something like white noise generation or noise generation of various colors and Gaussian or maybe just random distributions. We could have a Gaussian and, well, uniform, which is kind of boring because it's the default, but I could give you helper functions that allow you to give a range. Because as far as I remember, the random numbers in JSFX are only between 0 and 1. It gives you a floating point between 0 and 1. And I could have a library function that will give you one array or a random number between 2 values that you define. And of course, it's a simple formula. It's just a multiplication and an addition, but we could implement that helper. And I'm not sure I have other things that I want in this list of things to do. So maybe I will add them here. Things like dB to amplitude and amplitude to dB. Yeah, that sort of thing. We may want to have other things like discrete Fourier transform, and I know that JSFX already comes with fast Fourier transform, but it could be nice to re-implement the definition of a discrete Fourier transform for fun. And it may be faster for very small kernels if you have a very small convolution window and you're doing convolution using fast Fourier transform. If your impulse response is super short, then doing it with a discrete Fourier transform may be faster. But this is like, it's for the future. We'll get there when we get there. I'm reading about this a lot and I want to implement it. And Bo says, yeah, I'd like to try median filtering and see what happens. And Gaussian. Yes. Maybe if you already have a sorting algorithm, it could be trivial to just have something that calculates or find the median. That could be fun. Or like find the median and also the smallest and largest. Yeah. This is a sort of a to-do list. It's also a wish list. We'll see. We'll get to these things at some point. Okay, so we already have defined the array, so I'm able to index into the array and set certain values to the array. And then I can assert something about the array, like coefficients at position 2 should be equal to 3. And now, of course, this is not going to work because I have not defined this function. But I think I already see an issue, which is I can just allocate the array, and that is okay. But I think I would like a bit more safety when accessing the array. If I have an array of only 4 positions, I don't want to be able to set to a position that is not in the array. That's something that you can do in JSFX. It's not going to care if the position doesn't belong to the array, because the notion of arrays is something that we are constructing. So JSFX is just going to run this line just fine, but that's a bug. If you try to run this line, you're actually using memory from some other data structure. And if you corrupt memory that way, then things go out of hand super fast, and it's not fun. It's not fun. That's not how we play the game. So how about, instead of using the native syntax for assigning and for getting things from the array and to the array, instead of using the default syntax, how about we create some syntax? We create functions. So it will be larraySet, and then we need to pass the array, the index, and the value. And that will be something like the number 5. But remember that this should fail. It should verify that the index is out of bounds, and it should not corrupt the memory. So what we are getting with these functions is memory safety. And of course, if I am setting stuff like that, then I need to have a corresponding get function. Now, there are 2 reasons why I would need this. The first is for symmetry. If I have a setter, I better have a getter. But more importantly, it is because I want this data structure that is going to be created using this larrayNew. I want the data structure to have a notion of the size. I want to keep this number 4 around for later, for when I have to check the bounds. So if I do access like this, then I have no extra space in the data structure. So I guess my array is going to be a struct with 2 fields, one of which is the size of the array, and the second field is literally the space I'm going to allocate for the data in the array. So, okay, those are the reasons why I need a getter. So this is going to look like that. And then I will also try to access the index that doesn't exist, and I need to have some notion of error. So I'll have an error constant. And I will say that if you try to access anything out of bounds, you get an error. But more importantly, if you try to set something out of bounds, it doesn't corrupt the memory. That's the main reason why we are doing this. Now that I'm doing it this way, I'm kind of rethinking what we did with structs, because we are using this notation. I actually implemented setters and getters for the struct, but then I decided to not use them because there is this native syntax. But now, today, I'm realizing that this is not the smartest idea, because if you have some sort of bug where your label position is not a coordinate and you try to use the coordinate x, this may be out of the bounds and then you may be corrupting memory. So I'm going to actually stop the implementation of the array, fix the implementation of structs so that they use setters and getters and verify the bounds. And then I will return to the array. So I'm going to comment out all these things. All the lines I added should be commented out at this point. And I believe they are, but I'm double checking. Yes, everything that I added is commented out. So let's fix the implementation of structs. Let's find everywhere in the demonstration file. So this thing that I'm doing now is something that is a common technique in software development, mainly in the kind of software development that I do, like web development. I'm not sure that this approach is really common in audio programming, But what I'm doing is something called test-driven development, or in some cases README-driven development, but really it's test-driven development. I'm writing first things that use the arrays or structs or whatever to try to figure out the way I want to interact with the thing, try to figure out the API I want to design. And then I design the API. So I write code wishing that this function existed, and then I implement the function. And sometimes this is a good technique, sometimes it's a bad technique. It depends on the kind of exploration that you're doing and how you're feeling that day. There is no right answer. If you talk about this with some people, they're going to be super adamant about doing test-driven development always and forever, and I'm not like that. Do whatever works for you. In this case, I think that test-driven development is good because it helps me find their API. And there is something here that maybe this function could be part of the library. We'll return to this. Let's talk about structs. So we have the structs page. Oh, and this page is data structures. Yeah, that makes sense. So we have here a struct, and we define the struct, and then we define the field, and then we create the struct. And then here okay, so that's the only data structure we are creating so far. It's called labeled position, and let's see where we set and get to the labeled position. That's easy. There are only these two locations. So we'll have an L struct set, and then I need to pass the data structure, the position, and the value. So a very similar transformation to what I did here. And then to get, again, same story. And here we are. Now, if I run this now, the tests will not work. I think that they will fail catastrophically, saying that the function is not even defined. So let's go to the library and define this. I first need to find where I have my struct related functions. So I have define and field and new, and then I will define L struct set of my struct, and then so I want to check the bounds, right? So to be able to check the bounds, I need to know what kind of data structure this is. And I think that there is something weird going on here. So let's take a step back and revisit what we did 1 week ago, 2 weeks ago, I forget, when we first defined the structs. As far as I remember, a struct is just, when I allocate a struct, I'm just allocating some memory to hold the values. But that's not all there is to this. I need to also, the same way that I'm proposing to do with arrays, I need to store in the data structure itself its size to be able to do the bounds checking that I'm talking about. So, I guess what I'm going to do is I'm going to have a struct in memory. It will be the size followed by field 1 and then field 2 and so forth. So the idea of using enumerations here is fine, but it will not cut it because a field will be one off with relation to an enumeration. So let's revisit this whole implementation. We have an index, which is what is this? Okay, the index is the current size of the data structure that we are defining. So when I start Okay, Bo asks, what does struct mean? Is it a fixed variable? A struct is when you want to store multiple things in the same variable. The canonical example, and the one that I'm using in my example code, is when you have one variable that represents a coordinate. A coordinate is an x position and a y position. So there are two values, but you want to have one variable that is just two values. So a struct is just a structure where you put multiple values and you index these multiple places by name. So you can think of this as like subdividing a variable in a way that you can have multiple variables in a variable. And of course, this nests arbitrarily. So you could have structs within structs. That's what a struct is. And struct is a name that comes from C, but I'm more familiar with the concept used in Racket, which is a flavor of Scheme, which is a flavor of Lisp. So some of the things I am saying may make more sense in that context, but I believe that the C and C++ notion of struct is similar, if not the same. So that's what a struct is. It's a data structure to coordinate multiple variables in a single place. And I want to use structs, well, maybe for positions, for coordinates somewhere in the APIs, we may have something like that. But I definitely know that I need structs to have things like arrays. And then I can use a struct to store the size of the array and then the actual values of the array. And I can have a struct for something like a circular buffer. And then in the struct, I will store the size of the circular buffer, the current head position in the circular buffer, and then the actual data in the circular buffer, that sort of thing. Yeah, if that doesn't make sense, then you can ask follow-up questions. But that's this story on structs. Okay, so we have a struct index, and I'm not sure I love this variable. I mean, it makes sense to have an enumeration index when you start defining an enumeration and whatnot. But the struct index, I don't think makes a lot of sense, maybe. But I'll leave that variable name for now. So when you're defining a struct, you are calling this enumeration define thing. But in this case, I am now not using enumerations anymore because of the reason I mentioned, how everything is offset by 1 because of the size of the struct, which I want to store in the struct itself. So instead of using enumerations, I'm going to hard code this implementation. So when you start defining a struct, I will reset my struct index. And then I have this line here that I don't really understand anymore. Oh, I think I understand what this is. This is the base address. Okay, so because this is the base address, I'm going to rename this to like, I'll call this the definition. And I don't really have this value right here is not something that I have to care about too much because it shouldn't be used. This variable shouldn't be used like this. So maybe it's time for me to start defining my error, and all variables in JSFX are numbers. So I'm just going to put an arbitrary number here. It may not be the best option because if you get this out and this turns into audio, this may be super loud. But at least for now, that's what this is going to be. So if you try to use this to begin with, then it's the error variable. And then when you start defining this, then I will say that I am going to say that I'm going to allocate some memory. And that is going to be the definition of the struct itself. So I have two things going on that we have to keep track of. One is the definition of the struct, and one is an allocation of said struct. So for the definition, I'm going to allocate just one position. All I have to store in the definition is the size. And I'm going to have something like L struct. Or maybe this guy could be L error as well. You shouldn't be using this variable unless it's through define. So, and this can be L error as well. Or maybe I will have two of these. Maybe I'll have uninitialized. Because these are not really errors, are they? Yeah. Okay, so the memory index is initialized. It is 0. Needs to start with 0. So that one makes sense. So, okay. So I started defining the definition, and then I also need to start this. And this is going to start with a 0. Then, when I define a field, I can look at the definition position and add 1, because there is one more field in there. And then I also increment this. And this is what this function returns. So it starts as 0, and then it adds 1, which is the position of the first field. First field is in position 1. Position 0 is going to hold the size of the struct itself. Then, when I define a new struct, I need to allocate the size of the struct plus 1, and well, I'm going to call this the struct lowercase, and this is going to be a local variable. And that's what I'm going to return in the end. But I also need to go to the struct in position 0 and store in there the size of the struct. Now, I'm not in love with this hard-coded 0 here. This hard-coded 0 I don't mind too much. But maybe maybe I should. Let's see. So I guess one thing I can do is change all these names to be a capital S, because this is about the definition of the struct, not one instance of the struct. And now that I have this, I could have something that uses an enumeration. So let's use the enumeration. I'm going to enumeration define, and then I'm going to say that L struct size is equal to a constant in the enumeration. And then fields is going to be another constant in the enumeration. Then when I have this is yeah, right. Okay, I think that this makes sense. I think I'm starting to understand what this is going to look like. Yes. So this enumeration is the fields in the definition of the struct. And the definition of the struct only has a size. So where I am using struct at 0, I should be using this. Because in the definition of a struct, all I have is the size. Then I need another enumeration for an instance of a struct. So it will have a size and it will have fields. And with that, I think I take it back. I don't actually need this, guys. So maybe I will reset some of these changes using git. So let's see, these changes I think can go away. And I think that these changes may go away as well. Now let's see what we have. I have a struct definition, which is a variable that is not used anywhere. So I'm just going to get rid of that. Oh, no, it's not used anywhere because I have renamed this. Okay, so that is the place in memory where I am storing the current struct as I am defining the struct. That's why it's a capital S struct in this case. And this variable starts uninitialized. It will be initialized in the definition when I start defining a struct. Maybe these functions should be capital S struct as well. But then in that case, I guess this would be capital E enumeration. The difference is that enumerations don't have a notion of definition and instance because you cannot instantiate an enumeration. But maybe this should be capital E's as well, because structs will have this notion, arrays will have this notion, and circular buffers will have this notion as well of definition versus instance. Yeah, since we are breaking everything, let's break this as well. So all my instances of L enumeration are going to be with a capital E because it's a definition. And memory is something that we only instantiate. We don't really define. So it makes sense to have this as lowercase m. And then, of course, in here, everywhere where I have enumeration, I should also replace. And now I'm breaking things left, right, and center. This will be a whole mess. This is probably going to be the subject of the rest of the stream. So let's review this. We have an enumeration index that starts uninitialized, and then we define it, and then we add to it. That makes sense. Then we have a struct definition that starts uninitialized, and then when we start defining a struct, we allocate some memory for that, and then for each field we increment some memory. Now we have an enumeration for the definition of the struct, which only has a size. So where I'm using this, I should be using that. And I also have an instance of the enumeration, which is lowercase s struct, which has a size and it has fields. And with that, I can use an enumeration for the fields. So in the definition of the struct, when I start defining a struct, I start that enumeration and I start the definition, which is only one place. This place in memory is going to be for the size of the struct. When defining a new field in the struct, I go to the struct definition at position size, and I add 1. And I allocate one more enumeration. Well, I increment the enumeration. Then when allocating an instance of a struct, I need to receive as argument the definition of the struct. And what I do is I allocate some memory. That is, I'm going to write it like this. It's 1, which is the size, plus the definition of the struct at position size. So it's the struct given its size. That's what my struct is, and that's what I'm going to return. And then at this position, I am going to store the struct size. Okay, I think that all of this makes sense. So now when I'm setting, I need to receive as argument the struct, the field, and the value. And I think I want to make the point of mimicking what JSFX is going to do. So when you have an assignment like this, the result of this line is what is on the right-hand side. This is the output of this line. So that's what I'm going to do as well. So I definitely want to return the value, in other words. Now I need to look at the struct in position L struct size, and I need to compare that to the field. If it is invalid, if it's greater than, or if my field if given a field that is greater than the size, and I think it's even greater than or equal, but I have to think about this, then I will have an error. And I will just, I guess, return error. Otherwise, I'm going to do a bunch of things, the last of which is to return value. And what I'm going to do is I'm going to go to the struct. I'm going to go to the position where I have my struct fields, this guy, plus the field itself, and I'm going to assign the value. So I don't even need to do that line, and I don't even need this parenthesis. I will write the getter, and then we can think about the greater than or equal, and we can review the whole strategy to see if it makes sense. Now to get, I just need a struct and a field. And I guess again, I will have to check something like this. So maybe I will extract a function that will be private. So for that, I'm going to have 2 underscores, and I will call this valid field, or maybe is valid field. And that's going to return a Boolean. And given a struct and a field, this is going to do this check. Maybe I'll have it like this. How does that look? No, I'll have it like this, with a semicolon at the end. And then in that place, I can call this function. And in this place, I can call this function again. And I think I prefer everything like this. And then if the field is valid, then I do that. Otherwise I error. So I guess I'm going to say if not valid. And some people will say that if you have if then else, then you should not do a negation, but I think it makes sense. I'm checking for the error condition first, and then I'm doing the successful thing. So I'm doing, I guess, what would be called defensive coding. I'm first checking for errors. So I'm checking the bounds, and then in this case, what I have to do is just this. Yeah, let's think through. Let's review this whole thing, think through what we have, and then maybe write tests for this. Or, yeah, we'll change some of the tests to test that the setter is doing what it's supposed to do in terms of returning errors and setting fields and returning the value and everything. So we'll write some more tests and adapt the existing tests as well. So let's go through this again. Structs come in two parts, the definition and the use. The definition is capital S struct. The use is lowercase s struct. The definition starts uninitialized, and when I am going to define a new struct, let me put side by side an example of how I define a struct, which may make more sense. We'll see. Where is the definition of a struct? Yes, right here. So when I'm calling define to define a coordinate, I'm going to start an enumeration for the fields, and I am going to allocate some memory, which is the struct definition itself. So coordinate here is one place in memory, and this place is just going to store the size of the struct. Then for the fields, I can just define fields like this. For the fields, I'm going to increment that position, which is the size of the struct definition, and I'm going to create one more enumeration constant. So this is going to be an enumeration constant. This is going to be the next one. And I remember that I started the enumeration over here. But I also have enumerations over here as well. And what I'm doing in this situation is I'm saying that capital S struct, so definitions of structs have only one field, which is its size. And uses of struct, so instances of struct have size and they have fields. That's another enumeration. Then that's the end of the story for defining structs. Now to allocate a struct, I am going to allocate some memory. I'm going to allocate the size, and then so I'm going to store the size of a struct in itself. That's why this one is here. And I'm going to allocate the size of the struct itself. So for instance, when I'm allocating a label position, I'm allocating two items in memory. Because this starts at 0. Oh yeah, so one thing that I'm not doing here is explicitly initializing this to 0. Maybe I should do that. I think it's a smart idea for me to do this. As soon as I'm allocating, or I guess another thing I could do is just zero things out when I am finished declaring the memory thing. So I guess I could do some mem set, which is a JSFX thing. Let me look for the documentation for this. Yeah, so I have to pass 3 variables. One is the destination that will be, I guess, 0. I'm not sure. I'm going to leave here fix me how do we initialize memory to zeros? We'll return to this at some point. Okay, so I was thinking about how I do allocation. I allocate the necessary memory. Then in the position where I store the size, I'm going to store the struct size. And then I return the struct itself. Then to set something to the struct, I need to get the struct, the field, and the value. And I'm going to check if the field is not valid, then I error. And I need to pass the struct and the field. And to set, I only go to the struct where I have the fields, which is going to be position number 1, plus the field itself, which is an enumeration starting at 0, and this will be set to the value to get super similar, except that I just use this notation to get. Awesome. I'm thinking if I should extract a function for this part, which is repeated as well. I guess it doesn't hurt. So I'll have a function L struct field index given a field. And it will be as simple as this. But it's nice that we have this over here, because if the definition of the struct changes, then we have a single place to come and change this here. Now let's really think through the index situation here. Fields, for instance, this coordinate y is the number 1, because enumerations start at 0. So this is 0, this is 1. Right? My enumerations start at 0. Am I right? Yes, they start at -1, and the first one you define is +1, which is 0. -1 plus 1 is 0. So, coordinate y is the number 1 at this point. And then I receive something to set, for instance, to the struct. The size of the struct coordinate, in this case, it starts at 0, because I allocate some memory and I never set it to anything. Maybe I should. Yeah, maybe when I allocate the memory here, it could be nice for me to be explicit about this. Even if I have some sort of solution for initializing memory every place in memory to zeros, I think it's still advantageous for me to explicitly say I want to start this at 0. Currently, the size of my struct is 0. And of course, the thing that I need to return is the position in memory where this value is going to live. So I initialize this to 0, and then I should say it like this, right? So I allocate that chunk of memory, I set that chunk of memory to begin at 0, and then I return the address to that chunk of memory. Then, to check that the field is valid, the size of the struct is going to be, it starts at 0, and for each field it adds 1. So the size of the struct is 2. Coordinate at position 0, at position size. Coordinate at position size is the number 2. And field is the number 2. So the field is valid if it's less than or equal to the struct size. And that's the end of the story. Okay, that was hard for me to figure out, but it's not a hard line to write. It's just maybe my headspace is not right. I think that all of this makes sense. I read and reread 10 times. So let's write the test for this. And I did this bit where I changed L struct to be capital S struct. But I'm not sure I need to replace in every situation. Yes, in the setters and getters, I don't need to replace. So coordinate, capital S struct, which is this function, and then this function. And then fields, and then I allocate a label position. And then let's move down to the setters. So I can assert something about the setter as well. I can assert that when I set it's missing a parenthesis there. When I set label position, which is a coordinate x to the number 10, that should be the number 10. It should return the value that it was given. But if I try to set to position 999, then this should be an error. And when I get from coordinate x, this should be the number 10. Now, of course, there is a mistake here. When I'm getting, I should not pass a value, so I should only pass the label and the position. And I guess I'm going to have something like this, where I set to x and I set to y, and I try to set to coordinate y plus 1. This way I'm testing exactly the boundaries, and if I got this line wrong, then this will be a telltale sign. So I set to x and I set to y and I set to a value, to a position that should be invalid, so I should get an error back. And then I get from x, I get from y, and I get from a position that should be an error, so I should get an error back. Now, I have been coding for, half an hour now without testing. Very poor chance of this working first try, but we'll see. Yeah, it didn't work first try. Oh, it's saying that the function is undefined. That is because this is an auxiliary function, so it is being called here, and every function call needs to appear after its definition. You cannot look forward into function definitions. So I must take these auxiliary functions and put them above. I'm going to put them above the struct lowercase s part. Or maybe even this part, right? Because these auxiliary functions apply to these functions. So they are collocated. Let's try this again. Okay, so at least it compiles now. And is this not working? It seems like there is a gap here, and I don't think there should be a gap. I see 2, 4, 6 assertions. And how many do I see in the code? I see 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I see more assertions. So I don't think that the assert function is printing this poop emoji. And I know that the check mark is not looking the same as well. So maybe I should do something like pass, fail. And it's not as fun, but it's more explicit, so that's good. Yeah, okay, so I have 2 test failures. The first is, I think I even see a pattern here. Yeah, 2 test failures, and they both have, so they are the last and the fourth to last. So 1, 2, 3, 4. So in both cases, these are the lines where I am checking the boundary. So my boundary checking is wrong. I'm not getting back L error. That's what this is about. So let's try the obvious thing, which is this. If I just change from a less than or equal to a less than, it's going to be off by 1, right? Oh, that's interesting. So now these two pass, but everything else fails. Everything else that has to do with structs fail. I don't know, I think I'll have to debug this more carefully. So let me commit what I have. I return to a less than or equal, which was making more tests pass. And I will review the changes and I'm going to commit and then I'm going to investigate this further. So enumerations are now capitalized, that's trivial, and structs are now capitalized, and I changed from emojis to words. And over here, I have some assertions that I believe are right. Let's review the library itself. So I have now uninitialized, error. Uninitialized is a terrible name, isn't it? It should be like undefined, like in JavaScript. And I think I should have different values for this too. So I'll have like undefined is this and error is that. Now I can tell if a variable is undefined or if it's an error. Then we did the renaming in the enumeration. And we also used the undefined thing here. And then the whole implementation of structs, which is what we're going to debug and which is like, I went over this 5 times already, so I'm not going to review this more carefully. So now let's think about what could be going wrong and how to even debug this. Library on the left, demonstration on the right. I think I'm going to create some variables. Well, I'm going to first do the obvious thing, which is like to close this, close that, remove the effects from the track and re-add the effect on the track. Because sometimes that helps, but this time it didn't. So next I'm going to go into the inspector here and review some variables that I think should have certain values. For instance, I think that coordinate should be the number 2. Well, not coordinate, but coordinate at a certain position. So could it be that I'm not looking at the data structure the right way? No. But let's define, and that's why I wanted to commit. Let's define some throwaway code. For instance, debug equals coordinate at position 0. And that should be the number 2. But it isn't. It's not. Oh, that's because I am writing this code before the definition of the fields. Now it is the number 2. So that makes sense. And coordinate y should be... Oh, it's not the number 2, it's the number 0. Okay. So if my coordinate at position 0, in other words, the size of the data structure is the number 2, then I want my fields to be strictly less than the size. This is the correct implementation of that check. Let's do a full compile reset and hope for the best. Yeah, now some other things are failing. but at least the bounds checking thing is right. Okay, so I can get rid of this variable, and let's move on to the place where the tests are failing. Well, it's complaining that this is not equal to 10. So let's see, my test is failing because of this. So let's define this as the debug variable. And now debug is an error. So it's complaining that this is out of bounds. Why would that be? Well, let me commit one change that I know I like, which is the change fixing the bounds checking. The field should be less than the struct size. And this is just a debugging statement. Now let's go back to the library, and where do we want to have some kind of debugging thing? Well, I think what I want to do is to comment out all the other assertions, so we are only calling set once. This way, I am able to come to the implementation of set and test things more carefully. So debug is still an error. And let's go into the implementation of set. Over here, I can have a debug2 variable, which is field. I expect this to be 0. Debug2, I expect it to be 0 because coordinate x is supposed to be 0. Yes, debug2 is 0. Now, if I check for is the struct field valid? I expect this to be 1. I expect this to be valid. But debug2 is 0. So I think that the issue is in the checking of the boundaries again. But that doesn't make sense. We just checked this. But okay, let's have a debug3 variable. I know I removed the debug2 variable. In fact, I can even remove this variable at this point, but let's keep it there. So debug3 is equal to, let's say, field. I expect this to be 0 because I'm looking at coordinate x. And debug3 is 0. I expect the struct size to be 2 because we have 2 fields in this struct. So I expect debug3 to be 2. Oh, but look at that. Debug3 is 0. That is interesting. Now, let's just check that the enumeration is the right thing. So L struct size. Ooh, something spooky may be happening here. See this variable? There are 2 of them with a difference in the capitalization, but over here in the spectra I don't see both of them. That is going to be a problem. GEC says hello. Hello. Great to have you here. Okay, so yikes! I was assuming that the names were case sensitive and that they would be different, but maybe they're not. That could be a problem. Let's create a new effect for testing. How do I add a new JSFX? Come here to add. Then right click and then create new JSFX, and I will call this leafak/leafak_debug. I'm going to edit this, and I'm only going to have an init block where I have the variable a equals to a number. There is my number. And I'll have capital A, different number. And no, they are not different. Okay, that is unfortunate. That is so sad. I have to rethink a lot of things. Oh, but check this out. No. Yeah, it's just resetting the lowercase a to that thing. Oh no. Variable names are case insensitive in JSFX. On the one hand, I'm not really surprised with this, because JSFX is trying to be so easy to use, and if you're not careful about capitalization, then maybe having a case insensitive language is advantageous. Oh, but damn, that is so sad. I'll have to rethink a lot of things. Let me commit whatever I have. I don't really need this debug effect, do I? Whatever. This is just debugging stuff, and this is debugging stuff. So I'm going to reverse all of these, and I'm going to come back to my library, and I'm going to rethink all the capitalization in the variable names. Starting with the namespace. Do I want to have it as lowercase l? Maybe, right? I think I should avoid capitalization altogether, which is also a good argument for not using. I was even considering this, if I should use camel case or if I should use snake case, and I believe this is a pretty good argument for using snake case, which is what I'm doing already. Okay, so it is what it is. I'm going to look for all the places where I have a capital L, and I'm going to change it to a lowercase l. I'm going to do the same over here, and I'm going to do the same even with the file names. I'm going to start with the file names. Now, the file names are kind of weird because they are using this sans serif font instead of using a monospaced font. But whatever. And then I want to commit this because I renamed the files. Oh no, I am in a file system that is case insensitive as well because I'm on a Mac. So here's what I'm going to do real quick. I'm going to delete this effect. I'm going to move these two effects to any other folder so that they go out of the Git directory. Then I commit these changes, removing the files, and then I take the files, I get them back into the right directory. Oh no, what a hack. Today is not going as I expected. Then in the project where I'm using this, I'm going to remove it and re-edit. I probably need to rescan these plugins. Now it's lowercase l. Then in the code, I'm going to start in the library itself, and I'm going to look for all instances of l underscore and rename this to just lowercase l underscore. And we have 443. This is beyond me. I'm sort of listening. Okay, Bo, what's going on here is I was trying to do something fancy in the definition of structures. I wanted to do something called bounds checking. It's another safety measure to check if you are using the struct the right way. So if you mix structs up, or if you use a struct as an array, or if you use an array as a struct, I will be able to warn you. I will be able to catch your mistake, which is a good thing for data structures to do. They self-correct. And very importantly, they don't corrupt memory. If you use a struct the wrong way, you get an error back, but more importantly, you don't mess up with the memory that will be something else entirely, like an array. For that, I came up with this strategy of naming things differently. Capital S struct would be the definition of the struct. Lowercase s struct would be an instance of a struct. It's nighttime. Now, the issue is that in JSFX, variable names are not case sensitive. So lowercase s and capital S are the same name. Therefore, my naming strategy was not going to fly. So I'm going to rename everything to not use capitalized variables anywhere in my library, to not give you any indication that the thing is case sensitive, because it's not. So right now I'm in the middle of this, I was expecting to do arrays and circular buffers, but I decided that there was a bug. The bug being no bounds checking. There was a bug in the definition of structs. Then I found that JSFX is not case sensitive, so I learned something about JSFX, but that means that I have to change a bunch of stuff that I already did. And that's what we're doing now. We're changing all the capital L's to be lowercase l's. I guess I'm going to do all of them, and I'm going to check the diff to see if there is some other thing that I need to rename as well, or that I renamed wrong. Should not have been renamed. And I suppose that all these variables will also be lowercase as well. In fact, I think there is a good argument for me just doing this, which is taking the whole file and transforming to lowercase. And over here, I'll take the whole file and transform to lowercase. Now, this is heavy-handed, and I'm sure that in the diff, we will want to take some of this back. For instance, all of this, I actually want to be capitalized. They're just comments. So I can just come here and revert. Then save. And what is up? Got lost in the diff. What is up? I got completely lost. I'm going to revert everything. Okay, I think I'm getting back in a good stage. Let's do this again. Transform to lowercase. Transform to lowercase, save both files, go back to the diff, and find the places where we don't want to have this. I'm going to start with the library. Revert. What the hell happens? When I revert this, it applies to a bunch of things and messes everything up. That's no good. Command Z. Well, I guess the only answer is to copy and paste stuff that I want to revert. And that's kind of boring, but I'll deal. Okay, so those were just comments. So this is a comment as well. It's a section separator, and fix me should be capitalized. And then all of these I will need to review. Now for this, I actually need to come in and change some of these in these lines, but not other ones. Oh, this makes me so sad. Okay, I think I did it. Let's review this diff one more time, just to be sure. The only changes should be the lowercase l's and the lowercase s's and e's in enumerations and structs. Yeah, this is all about lowercase l's. Arial should be capitalized. And that's all. I think I nailed this part. Let's go to the demonstration effect. And in here, there is more. Data structures should continue being capitalized. And this file name needs to change. That's all right. And I want this capitalized as well. Okay, I think that all of this makes sense, but I will go over this again just because it's such a big change that we are doing. I want to be like extra careful with this. Okay, page needs to be capitalized. Okay, I want this to be capitalized. Okay. So I think I renamed everything. And one way to check this is that the effect should be working again. It should be in a working state again. We'll see. Let's go to Reaper, and I'm going to do the thing where I like delete everything and reload everything just for good measure. But here are our colors, everything is back on track. The data structures are still passing and failing the way that they were before. So all the renaming and refactoring seems to be good. Of course, I probably missed one or two things, and we'll see when we get there. Now we need to rethink the definition of structs. Or let's go over the whole data structures thing. The memory doesn't really change. The enumeration index is fine. And then here we have struct definition. And I guess I will have the name. So now I have struct definitions, and I have an enumeration for the fields in the struct definition. And I will call this the struct definition size. Let's find all the places where I'm using struct size. And in some of these, I will have to change to struct definition size. In these two places. And I think that is all. Yeah, let's see. So we have the current struct definition. Then we start an enumeration for the struct definition, which is the fields of the struct definition. We have struct definition size. Then we have the fields in the struct instance, which I'm just going to call the struct. And these are the size and the fields. Then I have lstruct define, and I start defining an enumeration. I update the struct definition. I allocate one position that will be the size. And then I set that to 0 and I return that. Then, when I define a new field, let's see what Bo is saying. When you're done, Leandro, and if you have the time, I'd like to carry you on FFTs. Yes, go ahead, ask away. I'm going to stream until, well, I have 7 more minutes. So ask your questions about FFTs, and I will try to answer them while I'm finishing this struct thing. So, lstruct define, lstruct field, and that is getting the definition, add position size and adding 1, and iterating one more enumeration, creating one more enumeration instance. Then, to define, this is not going to be the struct, this is going to be the struct definition. And this is the struct itself. So the struct is to allocate from the struct definition, get the lstruct definition size. And it's kind of weird because the size and the definition size are exactly the same value. They are position 0, but they are in different places. So I think it's better for me to have this separation. It could work by accident, but I want to have the separation more explicit. So 1, which is the size, plus the size of the struct that I'm defining. And this looks correct, is equal to that. So this is what I want. But I think I will have something like struct definition size, which is this. And I really wish I could type definition. I always get it wrong. So now I have the struct definition size, and I can replace these 2 occurrences with that. So the struct definition size is the struct definition, get its size, allocate the struct with its size, and set the position, the size in the instance to the definitional size, return the struct. To check if the field is valid, I get the struct, get its size, check if the field is less than that. Okay, that makes sense. That still makes sense. Then, to get the field index, I'm going to look at lstruct fields, but that's the wrong variable name. Then add field, which is like the enumeration. Then to set struct field value, I checked if the struct has that field. If it does not, I return an error. And then I say go to the struct, get that field index, and set the value there or get the value from there. Okay, that was a long tour of stuff to do. But let's see how we are creating structs. We define the struct and then we define the fields. And then to actually use this, well, I was going with the name convention of using capital C for this. Maybe I should have like coordinate struct, something like this maybe. Right? Yeah, I think it makes more sense to have something like this. Because then I can, if necessary, create coordinate equals L struct new coordinate struct. Yeah, I think I like this, so I'm going to have it like this. I think that this is the only place where this is relevant. Yes. And maybe I would like to have something like this. No, I think that this is fine. So let's see, label position is equal to that, which is using the coordinate struct. And then let's go to the task where we are going to do the setting and getting with the label position. And the tests still look right to me. Okay, so let's edit and full compile reset. And all my tests are passing. So we nailed this. Let's commit what I have, answer both questions, and get out of here, because we did not do anything that we proposed, but we did something else, which is bounce checking, which is a good thing to do. Let's see what we changed. Let's start with a library. So we changed the name of this variable to be definition size. And everywhere where we have where I'm indexing into a definition, I'm using that variable instead. Yeah, looks good. Then I also changed this function. I extracted a variable, the struct definition size. Then over here, I fixed this typo, which couldn't be helping anything. Maybe that this typo was what was making the tests fail. Some of the tests fail, I don't know. And then over here in the demonstration, I changed this variable name, and that was all. Everything passed. Okay. I am going to commit what I have. And I'm going to also commit this to my GitHub repository. It will not be available in Repack right now, but it is a start. If you are really enthusiastic about my library, you can go there and go on GitHub and download the thing. And I'm going to copy this new version into there. These two files. Push. And yeah, let's move on to both questions and wrap this up. Questions about FFTs. So FFTs split up sound waves into separate frequencies, right? Is it possible to do a leveler type of plugin for each and every FFT split frequency? And GSPT 4760 says, hey GSPT 4760, long time no see. It's great to have you here. Though you're catching us at the tail end, but you may want to watch the rest of the stream. I was proposing to do arrays and circular buffers. I ended up doing memory safety instead. So yeah, it is what it is. These things are not always linear. So yeah, FFTs. FFTs split up sound waves into separate frequencies, right? Yes, that's what an FFT does. An FFT is a fast Fourier transform, which is a fast implementation of an algorithm called a discrete Fourier transform. The discrete Fourier transform takes a signal in the so-called time domain. So it's just literally the sound wave that you would see in Reaper. Like if you record something, I'm not going to do that because I want to be quick, but if you have a sound wave in Reaper, you see the sound wave over time, it is just literally the position of the speaker cone over time. It's a graph of that. And an FFT takes a chunk of this. You cannot do this with a single sample. It takes a chunk of samples, and it's a black box. It's an algorithm that is going to spit out essentially the frequency spectrum. It's what you would see on a spectrum analyzer. I cannot help myself. I will show you what I mean. So here is my Reaper instance where my voice is coming through. No, I guess I will go to the other Reaper instance. Yeah, this is this right there, and this is muted, so I can go to my effects chain. I cannot really help this. I'll have to do it. So this is a tone generator. This is an oscilloscope. And I haven't written a spectrum analyzer yet, but we can just grab this one. So an FFT is going to go from a sound wave that looks like this. Maybe something more complicated and crazy. So let's put some other shapes in there. Whatever. So it's going to go from this sound wave into the, essentially that's what the FFT does. You give it a chunk of time from here, and it's going to output the numbers that would plot into a graphic like this. That's what the FFT does. Now, to your next question, is it possible to do a leveler type of plugin for each and every FFT split frequency? So what you're saying is you are taking each of these frequencies, or maybe not each frequency, but a bin. So you will take like a chunk of frequencies, like maybe from 200 to 500, from 500 to 1K, from 1K to 5K, and that sort of thing. So you can take these chunks of the frequency spectrum and do leveling on that. Absolutely possible, yes. Effectively, what you are proposing is sort of a multi-band compressor, but working in leveler mode. A leveler is nothing but a compressor that reacts differently. Its attack and its attack and release are much slower, and it operates in a slightly different way in that you set a target that you are trying to reach instead of a threshold. So it's a different usability kind of thing, but the principle is there. It's the same principle of a compressor. And what you're proposing is a multi-band compressor where you are splitting things and then you are compressing, or alternatively a dynamic EQ sort of thing. And yes, you could have something like that, and then you are leveling the different frequencies maybe to different standards. Like maybe for the bass, you want to target minus 20 RMS, and for the high frequencies, you want to target minus 15 RMS, and then the leveler will work in the different parts of the spectrum differently. So yes, that's definitely possible, and that's something that you can do with an FFT. Now, is this something that you want to do with an FFT? Maybe, maybe not. The advantage of doing this with an FFT is that, first of all, the algorithm is kind of clear. You can just divide things into the frequency spectrum, and then you can convert back, because there is the inverse FFT and there is the inverse discrete Fourier transform that gets you from this plot into that. This is not the full story, actually. You have to see the phase as well. So from the phase and the frequency spectrum, you can get back to the waveform. But so that's a straightforward implementation of multi-band compression or dynamic EQ. The problem in doing that is that, first, there is some latency involved, because the process of FFT and inverse FFT needs to work in chunks. So you need to store a chunk of audio before you can do this transformation back and forth. That will introduce some delay. And I see another message here on the chat, and that's my mother saying, "Hey there." So I think it's time for me to wrap up. But let me finish this explanation, and then I will sign off. So that's one issue. Delay is an issue. And the other issue is pre-ringing. When you do the FFT and you do stuff in the frequency spectrum and then you go back, you hear these artifacts. It's not ideal in some situations. It may be ideal in other situations. So doing the FFT and then back may not be ideal. Maybe what you want is to decompose your original signal into the different bands, not using FFTs, but using filters. You know how to do a high-pass filter, low-pass filter, band-pass filter. We learned about how to do those in Arrays streams, and we talked about this at length. So you can filter using a bandpass. You can filter the low end, you can filter the high end, and then you can do your regular compression or your regular leveler to the different bands, and then you can compose the signal back together. Now you need to be smart about how you are doing this decomposing and recomposing, because they need to overlap, and they need to overlap in a smart way. But you know all about this, Bo, because it gets back to that idea of designing speakers where you have two speaker cones and you need to filter the frequencies in a smart way. So that's how multi-band compression works. They filter the signal, they compress the different signals that have been filtered, and then they compose everything back. So that's one way of doing. Yeah, that's something that you can do with FFTs. May not be ideal. Maybe what you want is multi-band compression, a more traditional multi-band compressor using regular filters. And when we do filters, in some cases we use FFTs, but in many cases we don't. We just do that directly on the time domain. We manipulate the samples, we multiply them, we add them together, we do a bunch of manipulations to them, and we do the filtering on the time domain without having to go to the frequency domain and then back. So maybe what you want to do is to have a typical multi-band compressor working in leveler mode. There you go. Okay, let's see. Yeah, beans, that's what they're called. I think that's what the Gullfoss plugin is doing. Oh, okay. I don't think that there is a lot of information about how Gullfoss work. It's supposed to be like magic sprinkles on top of things. But yeah, maybe that's what they're doing. I don't know. Yeah, but that's a regular multi-band compressor. They already exist. Yeah, but what I don't know of, maybe it exists, I just don't know about it, is something that will do the multi-band compression thing, except that instead of specifying threshold and attack and release, what you specify is a target. And then it's more like in the leveler space of things, because a leveler is just a compressor, but it works in a different way. Like when I add recomp x, re-x comp, so that's a multi-band compressor. And in here I have my bands, but then I have to define thresholds and ratios. And when I am using something like the tri-leveler, which is a leveler, I can specify a target, which is completely different. So maybe it's just a usability thing, but you could implement a leveler, a multi-band leveler, using these kinds of controls, but this technology. As far as I understand, the technology behind this is filtering in the time domain, then doing compression, composing the signal back together, and that's why this plugin is zero latency. I think that's how it's done. I'm not sure. I'm not sure if the tri-leveler is multi-band. I don't think it is. And I'm not even sure what you would get from a multi-band leveler. I mean, what is the kind of signal that would benefit from this? I'm not really sure. I want to know that. But I need to wrap this up. I see you tomorrow over here in the channel, this same channel. I will be doing more recording. So I have done a lot of homework. I recorded shakers. I recorded new guitar parts. We are going to talk about recording with Aria over here tomorrow. Thank you all for watching. I'm going to sign off now. Yeah, have a good one. Bye.